Well, welcome. I am Mr. Murphy, and in this particular video we're going to be looking at Power Standard skill number 26. And in this particular skill we're going to be looking at graphing exponential equations in the form y equals a times b to the x power. And one of the things that we're going to be using to help us graph these is the y-intercept. And let's go ahead and take a second to look at what kind of graphs we're going to be doing before we talk about some of the things that we need to know. First, this is an example of an exponential function, and this is one that you'll be doing on your own here in a little bit. Y equals 1/2 times 1/4 to the x power. So it looks kind of confusing, but really if you know a couple of parts as far as what kind of graph this is going to be and what your y-intercept is, it's going to make the graphing of this function a lot easier. So let's talk about some of those pieces that we need to know about first. And the first thing that we need to know is we need to remember that equations in the form y equals a times b to the x power, these are exponential equations. So the graphs of these are going to be unique. Remember that the value for a represents your initial amount, what you're starting out with, that the value for b represents what we call our growth factor. And that growth factor is going to tell us a lot about the graph. The growth factor is going to tell us whether or not the graph is going to be increasing or decreasing over time. When our growth factor is greater than 1, that means that the graph is going to be representing exponential growth. So it's going to be increasing over time. You can see that as x is increasing, the graph is also increasing. Now, my value for b is going to be, should actually be when b is between 0 and 1. The graph represents what we call exponential decay, or we looked at story problems before dealing with depreciation. So that means that over time the graph is going to be decreasing in value. So you can see that as you follow the x-axis, you can see that as you follow the x-axis that the graph is decreasing. So that represents exponential decay. So knowing that if b is a number larger than 1, the graph is going to be increasing as x is going to increase. Or if b is between 0 and 1, so if it's a decimal like that, between 0 and 1, or a fraction between 0 and 1, then you know that the graph is going to be decreasing over time. So that tells us the shape of the graph. Now, the other thing that's very important is that value for a, that initial amount. Because both these graphs, if you notice, do intersect the y-axis. And the y-intercept, remember, is a coordinate. It's a coordinate where x is 0 and y is some number. So if I put 0 in for x in that equation, well, b to the 0 power is always, or anything to the 0 power is 1. So b to the 0 power would also be 1. So that means that your y-intercept would just be a. So using these pieces, it's going to make graphing a lot easier. Now we're still going to need a couple of coordinates, but at least if I know what the y-intercept is and if I know the shape of the graph, it's going to help me better pick some coordinates that will give me a good idea of what the graph is going to look like. So let's look at a couple together. So let's start by graphing this one, y equals 2 times 1/2 to the x power. Now, if you notice, my value for b is 1/2. That means that it's between 0 and 1. So that means this graph is going to represent exponential decay, meaning that it's going to decrease as we follow the x-axis. So let's, and also the y-intercept, the fact that it's 2 times 1/2. My initial value, my initial amount is 2. My value for a is 2, meaning that my y-intercept is going to be at where x is 0 and y is 2. So let's graph that and let's look at the shape of the graph here. So again, the y-intercept here would be 2. The fact that this is exponential decay means my graph is going to look something like this. Now I want to be a little bit more accurate. And so what I'm going to do is I'm going to set up an XY table. And I'm going to pick some points for x and figure out what the resulting value would be for y. Now, since I know the graph is going to be decreasing over time, what I'm going to do is I'm going to use -2 for x and a +4 for y, because that's just going to give me a couple of points that will give me the big picture of what the graph is going to look like. And you can always use 2 and 4, whether 2 is going to be positive or 4 is going to be negative. We'll see some different examples here. But 2 and 4 are ones that I like to use. So when I put -2 in for x, I would take 2 times 1/2 to the -2nd power. And if you recall from negative exponents, if we have a negative exponent, to make that exponent positive, we take the reciprocal of the base. And the reciprocal of 1/2 is 2. So in reality, I could look at this as taking 2 times 2 to the second power, which would end up giving me 8. Or like I said, you could just type this in on your calculator and you could get the answer that way as well. So I know one of the coordinates, -2, +8. So to find another coordinate, I'm going to put 4 in there for x. Well, 2 times 1/2 to the 4th power is going to give me a decimal. And the particular decimal that you get is going to end up being 0.125. Again, you can just plug that in your calculator and you get your answer. So now when I go to connect these, our graph is going to look something like this. And it's not going to ever cross the x-axis. The x-axis acts as a asymptote. So it's not going to cross the x-axis. It's just going to get really, really close to it. So that would be your graph. Let's look at another one. Here you can see this is an example of exponential growth because b is larger than 1. So that means my graph is going to look something like this. We know that the y-intercept is going to be at 3, so that's going to be one of my coordinates I'm going to be using. So now I just got to figure out, well, what are some other coordinates? So before, for the last one, we used -2 and +4. For this one, I'm going to use a -4 and a +2. Using the same numbers, I just flip it around. So now, and you could use any points, it's just that the reason why I like using these is, like I said, it gives us a clearer picture of what the whole graph is going to be. So when I put -4 in there for x, when you do that in your calculator and you take 3 times 2 to the -4 power, you're going to end up getting 0.1875. I'll just write this as 0.19. So in other words, at -4, 0.19 is just going to be just barely above the x-axis there. And then when I put 2 in there for x, that we could do without your calculator because 3 times 2 squared, square the 2 first, 2 squared is 4, times 3 gives you 12. So I'm going to have where x is 2, y is going to be 12, which is way up here. So the graph for this one is going to look something like this. So that would be your graph for this one, which represents exponential growth. So now I want you to try this one on your own. So I want you to take a minute, figure out what the y-intercept would be, figure out if it's exponential growth or exponential decay, and then go ahead and graph this. And so why don't you guys pause the video when you're ready to check your answer. Okay, so let's see how you did here. So for this one, you should have recognized that my y-intercept is at 0.5, which is going to be right here between 0 and 1. It represents exponential decay, so it's going to be something like this. So to get a clear picture of what that graph would be, let's pick some values for x and y. And it doesn't really matter too much what you picked as long as they gave you coordinates that we could graph. But I'm going to use -2 and +4 again. So when you do that, when you put -2 in here for x, we get 8 as our answer. And if I put +4 in there for x, and you do that on your calculator, you're going to end up getting a really small decimal of 0.002 is what I'll round that to be. So when you go to graph these, -2, +8 is going to be up here. 4 and 0.0002, like I said, would just be hardly off the x-intercept there. So now you can see your graph would look something like this. There you go. That would be your answer. Well, there you have it. That is Power Standard skill number 26. So hopefully after seeing some of these graphs, you have a better understanding about how to graph some of these exponential functions. Again, the key is just to make sure that you know how to identify those little pieces, how to identify whether it's increasing or decreasing by looking at that value for b. And also, that value for a gives away what the y-intercept is going to be. So hopefully you feel like you've mastered this skill, and good luck on your quiz.